Okay. Let me set the title. Binge watch. I guess this stream will be more videos from Hussein. Shit, I still can't pronounce it. That's so embarrassing. That guy, you see him in the title. I'm setting the title right now. I guess that's the plan for this video. Talks watched in this video, and I'm going to. Yes. Okay, so welcome to Lasergurkenland, reachable under lgl.zillyhoon.com. It's a vanilla Anarchy server, so it's unmodified and you are allowed to do whatever you want here. There are no world resets and there's no administration. Okay, so what do we watch? WebSockets. It's a stream about WebSockets.
Versus nope, nope, nope. Good old?
2 hours RabbitMQ, that's a bit long, isn't it? Microservice scaling with common sense.
What's going on?
Let's watch that one. Okay, so we need to discuss the microservices madness scaling with common sense. I might as well set that to the title of the stream. And we only watch this one video, but let's see. I can always. Okay, so that's set. Let's put it in the title. So having the video in the title is actually useful for me. So his name is no longer in the title, but it's in the description as always. It's useful for me so I can check if I watched a video already, because I watch a lot of videos on this channel. If I search it on YouTube and Lasergurke, it's like my public history of videos, whatever. Anyways, so that's that. You can skip to about Microsoft. You can also listen to the podcast. Oh, it's on his own website. I like to support that and click on his IP grabber link. Okay. Comment as? What the fuck? Where did it get my email from? The heck? Whatever. Okay, so let's go.
Guys, my name is Hussein and let's just...
Oh, did I advertise the server enough? Anyways, since the whole purpose of the stream is to get a high player count again. Oh no, did I press the wrong button? Was this the screenshot button or whatever? Okay, save. Okay, cool. Are we up and running?
Purpose of the stream.
Yes, okay. So please join the server. It's free to play on here. And the reason why I made the server is because I did not find any unadministrated vanilla servers. There are some Anarchy servers and they usually run on Spigot or Paper or whatever. And they usually also have a few plugins, and they... Well, the servers you find like 2b2t, obot6962.io or whatever, you know what I mean. Those servers usually have multiple players. We're talking about in the hundreds, and thus they cannot update to the latest version because this game is so unstable and Microsoft fucks things up. But that's why I decided to create this own small server here, and as you can see, this has barely any players, and it's in the latest version in pure vanilla, so it doesn't perform too well. We currently run on a 3.6 whatever gigahertz 8-core machine with 20 gigabytes of RAM assigned to this Java process, and I'm currently testing how these specs perform. And it's currently running local though. I'm using some whatever SSH tunneling, so it arrives at my home network. And yeah, so you might have some higher ping and if my own network at home goes down, the server goes down. So that's all not ideal, but it will be a temporary test for a few days. And I would love to see a higher player count here to see how this hardware performs, and then I will move it back to a data center, to a hoster. And yeah, that's that. Also, since the server is now running locally, I have it on my local disk, and I will do a backup of that. And yeah, since the world file is like about I think only 190, I keep saying 200 since 1 year or something like that, but it's only 190 gigabytes, but that's already enough, especially if you have some bottlenecking FTP transactions, whatever, then yeah, that can take some hours to transfer. Oh, that's bad. Anyways, so that's that. Please join here. So if you're interested in playing vanilla like in the old days, just on a small server, like I have the feeling these servers were more popular back then, when before, like, there were these mini games and Hunger Games and so on. There were, well, that was maybe my personal impression, but it was easier to find, or I wasn't this bubble that allowed it to me to find these servers. But anyways, where servers were either vanilla, or they just had basic plugins, and they were had a small player base, something like that. And I really missed that, so I decided to create that for you. And I saw one issue with small servers, that those were the days. Yeah, those were the days. I wish, what is this advancement? Patient women, I don't know what that is. Anyways, what was I talking about? Yeah, and the problem with these small servers back then, and probably also today, is that they are hosted by some 12-year-old kid just for fun. No front, by the way. No front at people's age or desires or motivation to host a server, but it usually had the disadvantage for the players that if the server owner loses its parents' credit card, or has to focus on school or whatever, or loses interest in the game, then the server goes down. Or if the hoster decides to, I don't know, slap on a new world, then we have a new world. So there's no consistency for players that you get with bigger servers, where there's a big community and a more grown up, even maybe team hosting the server, and you have a somewhat guarantee that the server will stay up and running under the current circumstances, with the current map or plugins or whatever installed, you know what I mean. And to ensure that, I already paid the server in advance for multiple years, so it is not tied to my motivation on playing here. I have to admit that I'm not too motivated anyways to play here for a longer time of a period. I actually played way more than I planned to play here. Anyways, so my main focus is just to keep the server up and running, play here maybe once a year, or when I have the urge to play on a vanilla server. And it's more like for you guys, so it's already paid. I'm just here like seeing how I can run the server most efficiently, how I can keep it up and stuff like that, how I can optimize my backup process, how I can ensure that the world file does not get reset, and maximize uptime and stuff like that. That's what I'm doing here. Right. So if that is something that interests you, then please come and play here. So who is the server, well, fun for? I guess it depends. Well, since there are no rules and also not too many players, you can actually decide yourself what you want to do here. So if you just want to play vanilla and build a house somewhere, that's fine. If you want this house to stay though, make sure that you go a little bit away from spawn, so no griefers can quickly find it and destroy it. And yeah, if you want to PvP, you can PvP here, you can insult other players, you can try to hack here, you can you know, all these nasty things. You can experiment here. Yeah, it's a very permissive server, so to say, and there won't be any consequences from, well, any administrative side, like banning you for being racist in chat or something like that. Well, of course, if you are rude, other players might be pissed off and try to punish you in-game, but those other players have not any like administrative powers or other like advantages over you that you couldn't get. They might have a better client, but you can also obtain that client, you know. That's the whole idea of this anarchy thing, I guess. But just because everything is allowed, it doesn't mean that this has to be a toxic environment, which, well, at some point, usually, well, it gets toxic, especially if you have multiple players. Oh, fuck. But yeah, since it's a small server, there's only a smaller player base, so it's less likely that it's completely fucked up and you can actually talk with people and so on. So if that is something that interests you, please join literally right now and get me 8 players on. Bring your friends so I can test how this performs, and then I can move on with my life. Wow, I'm so on fleek with my advertisement game today. I sound really desperate, but I actually am. Anyways, so let's continue with microservices. Oh wait, let me see what was ringing here. Okay. Fine. All right, so let's go.
Jump into the software news. We have some spicy, a little bit old news. Some of you actually sent me this article, and I gotta credit you. I got your name. Kashif Minhaj. Thank you so much for sending this article. So guys, microservices. We talked about them in this channel. They're beautiful architecture. We talked about their pros. We also talked about their cons, the bad thing about them, and how people are just jumping into this train like there's no tomorrow, and how bad this is. We need to stop it. We need to stop the microservices wreckage train. And then the Kalish Nad, hope I pronounce your name right, nailed this article. Let me repeat this. He nailed this article. It's a beautiful, well written, and I agree with almost all the points here. And I discussed almost all these points in my channel. I talked about them in different videos. I said, guys, hold on. Hold your horses, as the Americans say. Hold your horses. Scaling with common sense. So I'll leave the article below for you guys to read. The gist and the summary of this article is, guys, the old ways of scaling are not dead yet. Microservices horizontal scaling is good, but before you jump into that, realize the cost, realize the expense of maintaining that thing. Don't jump into this because it's fancy, because it's sexy, because it's just what everybody's doing. That doesn't mean that you're using this technology, that means you're modern, right? That's what people like to say. Oh, this is the modern way of doing it. Yeah.
Oh my gosh.
Scales? Who cares? All right. All right, guys. Let's just jump into all the points. There are around 14, 15, 16 points. We'll go through one by one, and you can use the YouTube chapters to jump into the one you're interested in, because they're just divided into chapters. You can jump into that. So the first thing we're gonna jump into that point is, and I'm gonna just read the first title, and then comment on that. Feel free to actually read the interesting topic in details if you want to, but I'm gonna obviously comment and critique the article from my way and how I understood it. So the first thing it says, comparisons are almost always meaningless.
Wow.
I could not agree
Bold
with that.
statement.
So it says, 1,000 requests per second on static data is not the same as 1,000 requests per second on an API that does a query on the database, or 1,000 requests that is a WebSocket connection, or 1,000 requests that does a gRPC, or 1,000 requests that does Volcano, REST API, GraphQL. Those are totally, so the metric using request is incomplete. It does not mean if your API serves 1,000 requests per second and my API serves 1,000 requests per second, that is not an equivalent thing. So I cannot compare. If you can serve 1,000,000 requests per second serving an HTML file, and I can serve 1,000 requests serving a sophisticated query that is synchronous. That takes a long time. Not only just a query, a transaction that starts and then queries multiple tables and
Oh fuck, I didn't
more
take the water with
processing.
me.
It's a long-running transaction. And then what does that mean if I use a message queue and I do this asynchronously? I can do millions of those requests, but I will get served immediately on those requests because they are just getting queued, right? But are they actually No, they are not. So comparison are really, really meaningless. So that's the first thing.
Well,
So
bad comparisons are meaningless, right?
Panel's just like, okay, should we use microservices or not? But this is not only, he's talking about in general, right? Think before moving to a new technology, right? So that's the first thing he is discussing. And this is a very interesting point. Valero is in tutorials an article that demonstrates great scale under narrow constraints. How we open 10 million concurrent WebSockets with a potato battery. All right, he's going a little bit over the board there. But yeah, while transmitting zero data, while are good to satisfy academic curiosity, should not be treated as general purpose user manual. I could not agree more. Theory versus practical is completely different, right? That's the part. That's what we try to bridge, right? The people who study, obviously, they give us a great input for innovation, but it doesn't always scale in practical when you have to try to implement it. Point number 2, scaling starts with well-built software. So he's talking about a poorly written Python web service may be able to handle 1,000 requests per second using $100 worth of resources, compute power, commodity software, right? While a well-written one might be able to handle the same rate with a 25 worth of resources. Scaling starts bottom up with a good code and good software. One moves on to scaling resources horizontally or vertically. I'm going to talk about that. We talked about that actually in this channel. After exhausting all easy optimization application code. Boy, I agree with this. So here's the thing, guys. You see that, oh, that's the problem we're making all the time. I see that my my application, my API, my backend only serve 1,000 requests per second, right? That means like one request is like what? Almost a millisecond, right? In this case, if I do the math right. So can I actually squeeze more requests per second on my application without doing any scaling? People will try to optimize or scale prematurely. I said, oh, this application just only does 3 requests per second, which is very, very obviously slow, right? That means, oh, let's just add more servers. Let's just add more applications. Scale horizontally. So your application will now, okay, let's spend 3 instances, 3 requests, so that's 9 requests per second because you serve them in parallel. But you did not do the first thing you should do. Why your application is serving only 3 requests per second? Why is it taking so much time? So that's like what? 300 milliseconds per request. Yikesy. Can you speed that up? Can you Squeeze as much performance as possible from the software. That's what he's talking about. Build well-written software. Sometimes you can. Sometimes the nature of the request is long running. That's why the request will take much time. And now you can think, okay, should I make this request asynchronous? That's another thing. He didn't mention that, but just I'm adding value to this article, right? Should I move to an asynchronous system where let's just submit jobs and then worry about the response at the other time? Yeah, you're offloading the request execution to the backend, and you better have a good backend with message queues, whether Kafka, whether RabbitMQ, whether ZeroMQ, whether any message queue that kind of pick and execute this thing. Uber recently moved to this architecture, completely asynchronous, which is beautiful, in their ordering payment system. I'm going to talk to them about that in another video. But this is very important, guys. Optimize your application as a singleton before moving to scaling. Just because your application is slow, you don't even have an index, and your query is slow because of that. We talked about indexing. Check out the video here. He told me an exercise data. I don't understand that one. So is the non-tech equivalent of premature optimization is bad. Okay. That's exactly what I said. Premature optimization is bad. Everyone has heard it. Appreciate it, but finds it difficult to practice. In the beginning, focus on writing good enough software, the refactor and improve as time progresses. Trying to build for web scale on day one can turn out to be painful, as the careful premature optimization gets thrown out of the window as the business and the user requirement change unpredictably. Because yeah, you want to ship, so you don't really care about optimization at that scale, right? Also, not every piece of all software has to be low latency and high throughput to begin with. On the other end of the spectrum is being lazy, ignoring common sense principle, leaving them alone. I didn't really understand what he's trying to say here, but essentially, just premature optimization is bad. And what are we talking about is, I'm going to flip this a little bit to premature scaling, right? Because you can still do optimization at the application level, as he explained on point 2. Point 4, KISS, don't be afraid. And boring is greater than cool. that's very, very nice, right? That's a very nice point, because keep things simple. If you can work with VMs, definitely work with VMs. If you can work with physical machines, work with physical machine. And if you back to point 2, where it's like, if your software is good, it's going to use the entire resources in an efficient manner. Okay, so it is absolutely fine to write a couple of bash script to rsync files to a remote servers to get something up and running. It does not have to be containerized and deployed on Kubernetes cluster on day one. Oh my God, I can't agree with this more. That's the problem. Everybody wants to automate everything.
Isn't a bash script automated anyways already?
We might get there after 20 years, guys, but I don't think we're there yet. Sometimes if you're building a small app, right, and a small architecture, a couple of bash scripts, just run a couple of bash scripts that does the job, and you schedule them with Windows tasks or with Linux tasks, cron jobs. That's the job. Keep it simple. Don't jump to Kubernetes and microservices just to do this one thing from day one. A lot of people pushes microservices in day one. I am totally against that. Unless you absolutely know that your application is gonna scale to the millions, to billions of services like Google, then do it from day one. But it's overkill. To me, it's just overkill. Keep it simple. The bottleneck is almost always the database. Wow, this is so underrated. Man. This statement is so underrated. The bottleneck is almost always the database. So true. Because your request is gonna fetch from disk at the end of the day, unless your server is static files. But queries, databases, your request eventually is gonna hit the database. And if your query is slow, then your entire pyramid will collapse, basically, because everything depends on that single query, right? So caching,
Rip my
proper
trap, by the way.
indexing, proper partitioning if you want to. Sharding, I wouldn't go there unless you absolutely need that, but yeah, basic database. I'm gonna take this.
Oh, yeah, that was smart.
Introduction to Database Engineering, where I teach you these things, the fundamentals, the first principles of the database. Talk about these stuff, what asset, talk about indexing, partitioning, sharding. When do we use when? I talk about protocols in the database, quick, and whether databases uses TCP today, but whether should we ever go there with pooling and quick and multiplex connections using HTTP2 or versus quick in the future. I talk about all that stuff in my course. Check it out. Go to HusseinNasser.com/courses. Yeah, RDBMs work almost always. Yeah, he's an old folk like me. I like RDBMs. A lot of people move to the NoSQL. Yeah, nothing wrong with them, but believe me, RDBMs work. Relational databases still work. I agree. Everything can be reduced to CRUD, 97%. And he's coding that. It's not obviously correct, but yeah. Represented as relational data that need ACID guarantees. You're almost gonna need ACID guarantees. Almost. Very few problems need MapReduce or schemaless storage, right? I don't know about this statement. I mean, to me, all the problems I faced is filled into that 97%. I don't know if that's small. What does small mean? Very few problems. What does that mean? I kind of have to disagree with that. We need someone who actually worked with problems that are absolutely cannot be solved with RDBMs, and you need schemaless storage, and you need NoSQL for that. So he goes through this. Everyone forgets to index. Well, I don't kind of agree with that. I think people are smart. They know about this. And they know about indexes. I mean, the first thing you spin up a database, you know when to index and what to index. I would qualify that statement with everyone actually over-index, maybe. Some people actually, like Uber, I believe, I keep forgetting. I think Uber moved from Postgres to MySQL. And then,
the last video, huh?
I don't know why, they didn't specify exactly why. Their
We watched.
was very weird, all that. But they moved from Postgres to MySQL. Again, I don't remember whether MySQL to Postgres or Postgres to MySQL. I believe it's Postgres to MySQL.
Yes, Postgres to MySQL.
Because they over-indexed. They just indexed every column that they are actually querying. That was bad because, guys, indexing is not cheap. Yeah, it's great. My database is slow, but if you use explain, and we talked about all this in my course and many videos on my channel, you can explain and see where is the path of the query takes you. Is it doing a full table scan? And you can add an index, but adding too much indexes can actually slow down your writes because those indexes are cheap. Ain't cheap. You're gonna maintain them. You're gonna add them. It's not cheap. So yeah. Everyone forget to index. I wouldn't agree with that. I think people are smart. I think people are index. I think people over-index, if you ask me, and that's the problem. Or they don't know what to index, which could result on problems, right? Because the database, guys, let's go back. I need to talk more about this. The database not always uses the index, right? The database are smart. It's written in a specific. Some people are now introducing AI into the database planner to decide when to use the index versus when to do a sequential scan. Sometimes a sequential scan, if you're filling a lot of rows, is way more effective than using an index because of the scattering. You gotta go to the index and go back to the disk and then go back to the index and go back to the pages, and you start. Yeah, this is gonna be a disaster in this case, the index. Sometimes the database pick sequential scan over indexing. Yeah, definitely. But yeah, look at this stuff, guys. So much stuff you can optimize without microservices, without horizontal scalability. Don't use an RDBMS. What? Okay, this guy loves RDMS too much. All right, so he says like, while RDMS are great, bearing the dramatic effect of the title, as said earlier, they are almost always the cause of the bottlenecks in a typical database backend application than the application code itself. Isn't that the same point he discussed? I feel he is repeating a little bit. So, all right, every individual query is a network round trip to the database that involves sending the query to the database, the database planning and execution of the query, and sending the data back over the network if it's possible to combine multiple queries into a single. Okay. So he's talking about, yeah, you can still optimize the database itself. If you're sending multiple queries on the same, because it's a TCP connection between the client, which is in this case the backend application, and the database, you establish a TCP connection, right? And then you start sending the queries. If you can minimize the chattiness between the backend and the database as much as possible by sending less queries. So he's giving an example where you can use the CTE comment table expressions and joins and nesting. So throw this on the database and let it do the work and give you the result once, instead of doing a query and then getting back the result, and then doing a query with the result from the first query and then joining it. You can do it client side. Sometimes it's more effective doing it this way, but sometimes it's effective doing join. I am afraid of using joins because joins are very slippery slope.
This is completely in the way.
If you don't know what the database is gonna do at the back end.
What did I think building that shit?
Scans, it's gonna use the index. Sometimes it gets really nasty, really quick. It gets so we try to avoid join as much as possible. Sometimes it's not possible.
I think it's done or something like that.
I agree with this. If you can minimize the number of queries, do. If not, then you have to do it this way. 9, networking I/O is really hard. Network is little as possible. Yeah, that's exactly the same point. He's repeating himself a little bit, but I like that. So, chattiness, guys. So we have a database, and we have the client, which is the backend application. And if a TCP, guys, is very expensive. We talked about that, right? So check out the 3-way handshake. Establish the TCP connection, 3-way handshake, and then every query you send comes back with an acknowledgement, and then you have to make sure that you actually respond. And there is so much going on there. So if you can send one request and try to shove everything you want in that request, that will be amazing. But sometimes it's not possible. That's why I keep talking about this concept. Check out this video where I coined this, I believe. Nobody actually did this before. Keep your servers closed and your database closer. I made up this, and I talked about it many times on my channel. Check out the video here. So you have to keep your servers close to your application client and keep your database even closer. You have to keep the database very close to the backend application as much as possible, so that you minimize this latency, this acknowledgement, these 3-way handshakes.
Yeah, I think
You have to, if you can, preheat this TCP connection. Preheat them. Use pooling as much as possible. I talked about pooling, guys. Check out the video here. So this is so funny. I talk about something and he just mentions it in the next point. So 9.1, connect little pool much. So he's doing the pooling, which I just literally discussed in this case, right? Pooling, guys, if you don't know, just start the application and open 7, 10, 100 TCP connection, preheat them. And then when request comes, you can use any TCP connection to execute the request, right? And then it doesn't matter because they all gonna connect to the same database, right? So that has been solved with HTTP2, right? And I'm pushing someone to use multiplexing with databases, right? I didn't see any project that does this today.
Am I too high already?
The problem with pooling is
isn't it the lower one?
Yeah, it's very great.
I'm too high.
I don't have to use the same connection to send the same query over and over, multiple queries on the same TCP connection. So it's a big deal. We talked about it, right? But that's a big problem. Don't use one TCP connection and send multiple queries on the same TCP connection. The database have no idea which query belongs to which response belongs to which query. So you might get very bad results. That's why you use pooling. And now the best thing is we have the same problem with the browsers. The browsers had the same problem. They send multiple requests on this to the same host. HTTP, you're pulling this page, and there are like 1,000 CSS files, a bit exaggerating, and 3JS JavaScript files.
I didn't even reach my
700
TMT
images.
yet.
How do you request all of them? You have to open multiple TCP connection, HTTP 1.1, and then start sending as much in parallel as possible. And the goal is you can only send one request per TCP connection. Minus pipelining. I don't want to talk about that because that's a bad idea. But yeah, that's the idea. So you can send as many as possible, but you're still blocked, right, with this number of TCP connection in the browser. So the browser did is that they invented HTTP2, which is allow you to use one TCP connection and kind of coat your request with headers that lets you know, oh, this request belongs to this request. There's a stream ID with every request. It goes so you know, right? So you can multiplex multiple requests in that same TCP connection. Beautiful design. We need to bring this to databases. I don't know why nobody's talking about this. We need some database to support. I'm not going to say HTTP2 because it has its own problem, and then database people don't like HTTP
water.
because it's a what's the word they use? It's bloated with headers and stuff. Fine, use Quick. Now, the problem with UDP and blocking, I don't think it's a problem, to be honest, because databases are usually in an internal network, and UDP will be allowed. So you're fine. We need a database that support Quick. Please, someone build that database that supports Quick, so that our backend application can create a beautiful single connection and then multiplex the CI on this single TCP connection, the single connection. Pooling. Latency is the metric. I agree. If I can send a request and I get the lowest latency the possible, that's the best thing.
Okay.
Latency translates to many things, right? And doesn't mean like how long should it take to actually open the connection and establish the request, pack the request into this connection and send it, and then execute the request on the back end. That gives me the question, what is really a request? A very, very philosophical question. I talked about it right here. What is a request? What's a request exactly, guys? What is a request? Because if you think about it, it could be, which layer are you? Are you on layer 7 talking about request? Are you on layer 2 talking about request? That's a frame. On layer 3, that's just an IP packet. On layer 4, that's a TCP packet. On layer 7, that's an HTTP packet, for example, request if you're using HTTP, right? Or using the protocol that is built on top of whatever protocol you use, right? Database, Postgres uses their own protocol, Redis uses their own RSP, REST protocol, whatever. The internet is a wild, wild west. Imagine a well-built, highly optimized low-latency service with high throughput that handles 100,000 requests a second. Ooh. 1 million concurrent users start sending requests to it, widely varying, right? From varying 3G, 4G, and broadband network over HTTP connection. The service will instantly respond to an incoming request on a connection, but the connection to the user over the internet is unpredictable. It may take 50 milliseconds or several seconds to write a response. That's the server writing the response, right? For this period, and when you see writing the response, that's just I can talk about this for 30 minutes. Writing the response is just writing the packets in TCP and getting acknowledgement for each packet, right? So that's what he means by writing a response. The full response is going to be a layer 7 response, but at the packet level, it's going to break down into multiple packets, and each packet needs to be acknowledged and ordered and garbage, so much stuff. For this period, the connection is held hostage by the user's poor network and its app. That's true, because if I can't get acknowledgement on my beautiful small packets, I can't send the response, and I'm holding the connection hostage and resources, precious server resources hostage. That's how slow loris attack works. If you have never heard about it, slow loris is an attack that uses a slow network to simulate a slow network on a server, on a client, so the server can actually spends up a lot of resources on this. So yeah, it says typically just deploy HA proxy, Nginx. We talked about all these in my channel. Deploy load balancer, detect all this stuff. Most of the stuff, Cloudflare have services to detect this. Layer 7 proxying, Layer 7 reverse proxying can actually detect this thing and kind of what's the word? Shift the load onto something else. Instead of your backend servers, shift the load to the load balancer. And then Nginx and HA proxy are built to deal with these things. Caching is silver bullet. Ooh. Caching is great. Since RDBMS squares are expensive, add layers of caching. Again, I don't know what he says exactly here, but I would only add a cache if you absolutely need it, because cache maintenance is hard, man. It's very hard. I mean, he talked about the dump caching is the best caching. When a request looks up data in the cache and dumps it directly in the response, that's a dump cache. The cache logic has no understanding of the semantic structure of the data stored and just does byte out. Dump caches are nice, and the application needs concern about parsing the data. But again, you only need to, how do you trust the cache? That's the bigger problem. That's why we have write back cache and then the write through cache, and then how do you invalidate the cache? One computer science professor, I forgot his name, he says the hardest problem in computer science is cache invalidation, and I can't agree with that more. Some application state might not be bad. So yeah, I used to be against this. I used to be the kind of guy where, oh, stateless is the way, always be stateless. But I changed with the years as I grow. I think stateful applications are needed. Sometimes you need your application to be stateful. I actually ran into it when I built a game with WebSockets. What I needed my players of that particular game to be in the same server, and that's stateful, right? And instead of having a third layer that maintains a cache and have my application statelessly query for the game state, I put all of them in one server, and that's challenging to build with WebSockets. I actually couldn't build that. I had to write. I didn't do it yet, but I have something in mind to have the layer 7 proxy actually terminate the connection and then have a knowledge of the content in order to do this. I don't think you can do it with WebSockets. I might be able to do it with long polling, for example. So I'm still thinking about that. So might actually change my design to a stateful design, because yeah, stateful is great, because if I have my mirroring data locality, my cache is in beautiful same place. That's the best thing a backend engineer can ask for. HTTP database can be e-tagged. 304 too. Oh yeah, this is underrated, man. E-tags are so underrated, to be honest. I don't know if he agrees or disagrees with this, right? I like e-tags. If you know what you're doing, if you've built A-tags yourself, if you actually generated the A-tag, the browsers can help you so much. But it's a double-edged sword. If you don't do it right, you can serve your users with bad old stale cache data. I talk about e-tag, guys. Check out the video here. This is not widely as is surprising to me. Client-side HTTP caching is what underpins the large scaling content delivery. Yeah, it's just with static data you're good with e-tags. It just takes care of things. The browser caches, store the hash in e-tag. Check the server if the file has changed by sending the e-tag. If it hasn't, the server responds with 304. Okay, we know how e-tags work. They work beautifully HTTP APIs too. And we know that 97.42 all APIs in the world are HTTP JSON. Return the JSON response, uses the reference, and if the response hasn't changed, why send the response all over again? Nice. We send an e-tag with all HTTP requests. Kite. Kite is the software they use. This is a little bit, I don't know what he's trying to say with this, but e-tags are great, guys, but I have no idea how we're gonna effectively build your e-tag in a database query, because the act of checking for an e-tag require a query to the database, and you need to maintain the state. So you might need to maybe, I do a get, right, and I receive an order, and I then query the database for the orders, and then I respond, and I generate a unique hash for the orders, and I respond back. So now if the user sends me the same e-tag, how do I know to actually respond back with that same, say, hey, didn't change? How do I know that e-tag is already generated? I have to query the database, right, to check if it exists or not. You can avoid that by generating your own table with an e-tag and like some sort of a flag that tells you if the order has changed or not, and accordingly respond, right? But that kind of just destroys the concept of HTTP semantics with GET, because in this case, when you do a GET, you can actually write, where GET is actually a safe method. You might get away with it, but
get away.
It's not easy to implement, in my opinion. Allocation is expensive, memory allocation. So he's talking here about garbage collection data. I agree with that. It really depends, to be honest. I think he's over-exaggerating this on it. Yeah, I agree with some of his point. I don't agree with everything. This is a little bit exaggerating to me. If your service is the bottleneck, and it's receiving thousands and thousands and thousands of requests per second, then I agree. The GC languages, garbage collected languages, can pose your application, can pose your request, and slow down your queries as a result. Meet Linkerd. Linkerd is a sidecar proxy. They built their sidecar proxy using Java. And Java, you know Java, it's a garbage collected language. And the JVM machine has like 100 megs or something like that. It's very big. So after they scaled, they noticed that there are these pauses that just freezes the application, and requests cannot be met. So their tail latencies are just shot, and it's very slow. So they moved their proxy from Java to Rust. Rust is not a garbage collector language, so they brought, I think, their runtime size to 1 megabyte, I believe. It's nuts, man. But that's only for them. So, what's your name? So Kalish here is contradicting himself, to be honest, because he's saying, oh, don't use garbage collected languages. right? Because they are expensive. At least that's what I thought he said, right? But he's in the same time, he's like, yeah, use other language, but this is, to me, this is premature optimization. Unless this is what he said, right? I don't know. Memory allocation is expensive, especially in GC. We write our high throughput services in Go. Simple to learn, highly productive, which is in GC line. Thanks to our services mostly being I/O and not heavy in memory. That's true. Because if it's in memory, then you're gonna start feeling the garbage collector. He's right. We are unlikely to run into any jar there, but there are common sense principles that we use when writing Go. They are applicable to other languages as well. On hot path, allocate as little as possible, reuse buffers, try to avoid. Okay, I'm sorry. So he's not telling you to not use garbage collection language. He's telling you to be aware of this, because allocation is expensive. So try to not allocate memory unless you absolutely need it. I apologize. Okay, make sense. But think about that. Sometimes you need to switch your programming languages because you need to write a lot to memory. So garbage collection could be a problem. The GC poses can be hurtful, so you might want to switch language in that case. But most of the time, if you're doing what he's doing, what he's asking for, which is a beautiful, beautiful point. Thank you so much. This is good. This is good. I like it. Multi-threading and concurrency are necessary but hard. Oh my God, he's reading my mind. I talked about this right here. Check out the multi-threading. When it's come to me, I try to use a single thread application as much as possible, and try, if possible, squeeze everything out of it, because it's way easier. Concurrency are great. Multi-threading is great. I mean, most proxies are multi-threaded, but it's so goddamn difficult to build, right? Go, I know Go has their own now multi-threading system that makes it easier, but what if you want to access the same resource? It's complex, so I talked about that. So I'm not gonna spend more time talking about this. Some technologies are generally slow. Use fast technologies. Python is slow. Ruby is slow. Frameworks like Aurora are slow. Yeah. Here's my point. Comment on this. You can use technologies as long as you know how they work. Do not use stuff that as a black box. I am completely against this. If you use Ruby and you know it's slow and you know how to work against it, by all means. However, if you use a technology, a lot of people use React blindly. They don't know how React works, and they complain about the performance later because you don't know how it works. So you're using it for a different task than it was intended to be, right? So these are very, very critical points to understand. WebSockets. A lot of people use Socket.io instead of WebSockets, and they complain about some bloat that Socket.io had. Same thing. Some technologies are slow, so I had to agree with this. You have to know what to use and what not to use. Scale horizontally, vertically, and enterprisingly. I like this point a lot.
What is enterprisingly?
Scaling vertically is so underrated. A lot of people just say, oh, let's just scale horizontally. Try sometimes scaling vertically, because it's way cheaper sometimes to scale vertically. Cheaper in terms of, yeah, you're gonna pay more money, but it's gonna take less maintenance in the future, because, and he said it very nicely, so scaling horizontally is complex, because the moment you scale horizontally, you need a load balancer, you need a reverse proxy. You need to maintain a reverse proxy, you need to teach the reverse proxy. The reverse proxy becomes the bottleneck in this case, because it's routing request, and now you have to scale the reverse proxy by adding a DNS router on top of that. So you can get very premature scaling very, very quickly, especially with a container. They're so easy to scale so that Kubernetes get added on top. I'm gonna add my 2 cents of Kubernetes at the end. Human impediment, yeah. Sometimes, often, a managerial bottleneck is a bigger impediment to common sense scaling than network I/O. So essentially, he's talking about a lead who pushes a distributed NoSQL database where an SQL-lite file is sufficient, or a service mesh microservices instead of couple of processes behind. Oh my God, I can't agree with you more, my friend. That's the problem. So if you get some CTOs, right, or just some leads that says, hey, there's this shiny beautiful thing that's called NoSQL. And it scales. It's built for scale. Let's just scale, distribute it, and all that stuff. Where your problem can be solved with a SQL-like file. Your problem can be solved with a simple Nginx. Your problem can be solved with HA proxy, with Envoy, and you just adding this garbage. You add services and make microservices, and or a computer, or you can just spin up an EC2 instance and solve it. My thought, guys, my final closing thoughts about this, and this is gonna get a little bit conspiracy theory. That's just my conspiracy theory voodoo hat, I think. And the whole thing is just my opinion, and it's all allegedly, all right? It's just all me. Think about this. Here's what I think people moving to Kubernetes and microservices. Here's what I think why. AWS started the cloud era. Amazon. They took most of the customers. Everybody's in AWS. Everybody's in the cloud. It was a smart move from Amazon. So everybody's in the AWS services. All their money, most of their money is coming from that. It's so much, tons of money. So now, Google comes in and wants to dominate the market. And Microsoft comes in to dominate the market. It can't. It's just, the market is just saturated by AWS. So what should it do? Let's invent this idea of cloud lifting and locking, which are not essentially incorrect problems. They are real problems where you're locked into AWS. Is that a serious problem? I don't know, it depends on you. I'm not on the cloud. But if you build an application and you spins it up on AWS, you're using AWS Lambda, you're using these technologies, you're using EC2, you're stuck to these technologies. That might be a bad thing or it might be a good thing, but I think Google just blown it over the top. It says, you're stuck to this. Let's move to this idea of Kubernetes. What is this? Oh, it's just like the operating system of the cloud. You install Kubernetes, and then you spin up your containers, and then that's it. It's just a PaaS. It's a platform. It's a platform as a service. So you take that stuff to Kubernetes. If your application is on top of Kubernetes, and these containers are talking to each other, you just lift and shift to another cloud provider. So now the container orchestration wars started in 2016, I believe, 2015. And Google clearly won this war with Kubernetes. Why? Because containers were born. Application deployment became so easy that people got so greedy, spending multiple of them. Managing container became so hard. You need something to orchestrate the containers, so we built Kubernetes. And now Google advertises Kubernetes like there is no tomorrow, just so that everybody moves from AWS to Kubernetes, so that Kubernetes is actually literally a ship that is designed to take the money from AWS and just ships away. Google doesn't want to take that money. It doesn't have to be. It's just the idea is like, how do I move people from AWS? Kubernetes is the solution. Again, that's just my conspiracy theory hat. I'm wearing it. But I think that's what's going on. Because it's crazy what we're doing, guys. It's crazy. Why is Mike's donuts shop moving to Kubernetes? That's just nuts. It's a donut shop. It's a garage. Why do you need containers, for God's sake? You don't need any of that stuff. Spin up a VM and that's it. You don't even need to horizontally scale. Why? We're over-engineering, guys. We're over-engineering. We're over-killing ourselves with this stuff. But that's my thoughts, guys. What do you guys think? Let me know in the comment section below. I'm gonna see you in the next one. Sorry for the long video, but I had so much to talk about in this video. Agree, whether you agree or disagree, like this video or dislike it, right? And let me know your comment section, your opinion in the comment section below. I'm gonna see you in the next one. You guys stay awesome. Goodbye.
Stay awesome. All right. Since I'm still motivated to continue here, I guess I'm forced to talk. No. Okay. Like this. Right. Yeah, or I watch another video. Nah, I don't feel like. Okay, I guess I'll just continue here without a video. Oh, maybe let's watch another one. Anyways, he had a short one that I was interested in. The one about, oh, I have my filter in here. 50 minutes ago. I wonder if he activated. Yes, he actually set it to Creative Commons license. So that's cool that now I'm more safe on the legal side. Awesome. Because written permission in a YouTube comment is not the best. NAT Slipstreaming vulnerability explained. I have no idea what it is. It sounds super interesting. And I'm going to add that to edit the stream to another video. I could have left the title binge watch Hussein channel. Oh, boy, please don't let me pronounce his channel name ever again, or his name, because I can't. Okay, I change it back. Well, I changed the video title to Microservices Madness / NAT Slipstreaming. What do you say? So I have both videos in the title, like 5 head, something like that. Okay, very efficient. Let's go.
NAT Slipstreaming is a new attack discovered by Sami Kamkar, and I want to illustrate it.
Uploaded 50 minutes ago.
In this video. So if you're interested to learn about that attack, stay tuned. So I'm going to
100 views.
What I'm going to do and then show you graphics and all that jazz. So the goal of this attack is we have a victim and he or she is running a precious private service that we want access to. But that victim is behind NAT, and LAN and a NAT, so it's impossible to access, right? And so let's say it's running on 8080, and that's what I want to access as an attacker. How? Maybe it's a Jenkins server, maybe it's an email server, I don't know. That's the goal of NAT streaming, and that's NAT Slipstreaming. So the steps are, victim will visit the attacker web server. So it will be a URL that's running a web server on the attacker, and that downloads an HTML page. Not fancy, right? Nothing fancy so far. So that's legitimate. Just a click of a link. You download the index.html. That page makes a special post request using JavaScript, because that's what runs in the browser. And that post request contains a body that contains something called a SIP message, right? It has a lot of stuff, but it was a very well-crafted post message that has a lot of body, and part of it contains a SIP register message. And I'm going to talk about what that means. But what that means is it's a special protocol called the Session Initiation Protocol to allow voice over IP and other stuff as well. And that special message instructs the router to open any port on the network on that machine. So you might say, does the router just randomly opens port? No, that message is special. We're going to see how the trick is done in a minute. And then finally, attacker will access the victim service on the open port that the router just opened. Let's just jump into it. So here's my beautiful victim, and he's been running on port. There's an IP address 10.0.0.2, so it's behind NAT, and it's running a service code on port 8080. So maybe it's a Jenkins server or anything like that. Right? It's behind router, so that's the gateway 10.0.0.1, and there's the router has a public IP address 9.8.7.6, and this is the attacker HTTP web server, and it's running on port 5060. It's very critical that it has to be 5060. Otherwise, this whole thing doesn't work. You might say, Hussein, why 5060? Because 5060 is actually the SIP protocol port, and it has a special semantic in the router. And if it sees that with the SIP message, it actually activates something called the ALG, which is the application layer gateway, which actually does the opening of the port, ironically. How about we jump into it? So the victim will visit that page, just normal link, right, and then makes a request to the router, and we're gonna review how it happens in NAT here, guys. So if I make a request, what does this require? So it's a GET request, right? The target is 12.3.4 and on port 5060, and the source is 10.0.0.2 on this port, random port 7641. That goes to the router. The router will create a NAT entry and start mapping this internal port, this inter IP, to an external port.
Oh my gosh, where's this fucking skeleton? I hate my life.
So 9876 and create a random port 6543. It could be the same port. Who knows? Who cares? And now this is the new packet now.
Looking at the angle, it has to be
to the internet, because 10.0.0.2 means nothing.
Oh my gosh, where is this bitch? Whoa! Please don't kill me, bro. Why is he doing so much damage? Where's the skeleton, man? Fucking spooky skeleton. What the heck, man? I need some client that shows me stuff. Like, fuck this, I'm ignoring.
Who knows? Who cares? External port and external IP that is assigned by the router. So 9876 and create a random port 6543. It could be the same port. Who knows? Who cares? And now this is the new packet now, because we cannot send that naked packet to the internet, because 10.0.0.2 means nothing of the internet. So we have to do a NAT translation to work at this translation. I talked about NAT, guys. Check out the video. So now the router just sends this packet to the web server, the attacker, and then the attacker will receive that and say, okay, let me serve you this special index.html that contains this malicious attack. So it's the index.html. So now the attacker will respond back with 200 OK, but now what is this destination? The destination is the port that comes back. So 6543, and this is the public IP address of the router. And sends back the information, says okay, 200 OK, here is my index.html page. The router looks at it, looks at the table, says okay, 98766543. Oh, that maps to this internal IP. Let me swizzle that in the packet and then send it to the right user. So far, nothing is wrong with this. This is a legitimate request, but we're gonna peek into what's going on there. When we peek into that, it's an index.html that sends a post request. So that victim gets back the malicious HTML page, and that HTML page has a JavaScript that immediately submits on load, and it sends a post request to this IP address, HTTP 1234560. And this is how the post request looks like. It's a simplification, but the idea here is I'm going to send a post request. I'm going to send the random body so that I can, and that's the trick, and that's what Sammy explains. If I can neatly build this post request so that it splits nicely into a single MTU TCP packet,
so that the whole thing up to here becomes one TCP packet, and the second TCP packet, because it's too large, now we have to split it. We split into another packet. That's the trick.
The fuck, man? Oh my gosh, who of you bamboozle beers stream sniped me? Someone is ringing the bell and like running, giggling away. I'm sure it's the 0 viewers that are currently watching that are messing with me. Oh no, a mountain. I hate my life.
So now my post request becomes 2 TCP packets. So now that's how HTTP works, right? I'm sending the HTTP request. I'm going to break it into two TCP packets. I'm going to send TCP packet number 1 and then 2. That formulate my request. Now, I'm going to refer to this as the green packet, which is good, and I'm going to refer to this as the red packet, right, from now on, right? And look at this. It says register SIP contact 002.10.000.2.8080. So that's the service I want to access. That's the attack. That's the victim service. That's the Jenkins server. All right. So we'll go through the green one, which is the actual post request. We'll go through the same exact process. It does the NAT and all that stuff. But I'm not interested in that. I'm interested in the second TCP packet, which is the red one. I take that TCP packet. I send it, right? This is part of the post request. But look at it. This post request, this part of the post request has nothing but that beautiful message. So the router looks at it and says, whoa, wait a second. I can't just let this go. This is a special thing. The router has something, most router has something called ALG, which is Application Layer Gateway. And it's a software.
The fuck are these names today?
And says, wait a second, 5060, I know this port. That's the SIP protocol port. Let me actually inspect this. If it inspects the packet and says, oh, register SIP, contact 10.0.0.8080. Oh, the client wants to open a SIP connection. Let me just follow the instruction of the client, because to the router, the client just made this request, not the attacker, right? That's the trick here. The combination of this plus this will instruct the router, again, only if ALG for SIP is enabled, to open port 8080 for 10.0.0.2 and adds a new NAT entry so that it allows external access on port 8080. And nobody asked for that. It was just a malicious
What is the
JavaScript
zip anyways?
post request.
How do I turn it off?
Genius,
What do I
dude.
need it for?
This is genius. All right. So this is how the NAT table how it looks like. Now we have a new entry, 10.0.0.2.8080, and this is the external IP, and this is sample, maybe some other port, and then that's it. We have a new entry. Now, the next step is that the attacker just accesses the service. What does it do? The attacker sends a GET request, because it knows somehow this is a HTTP server, which is the Jenkins job running on 8080. It sends it to port 9876 on port 8080. That's the destination. And then its source is the same port and IP. And it sends it. And it says, wait a second, what is this? 98768080, do you want to go there? Oh, I do have an entry. Let me translate that, sir, for you to 10.0.0.2.8080. Let me swizzle that. And then let's just send it to the victim. And that's how it works. So guys, to enable this attack, first of all, there's a lot of work. And I encourage you to read Sammy's article that he details a lot of stuff. Because first of all, how would you, as a JavaScript app in this case, know the IP address of the host?
Try them all.
Usually this information is not accessible to you.
It's not too
That's
many,
a
isn't
challenge.
it?
He runs into a challenge like, okay, I'm gonna get into this, then 002. And the second challenge is that how do you know the public IP address of the router? That's the second challenge, right? So there are all these challenges that he actually breaks down and to go do that. And the first video I made, actually commentating on the article and just discussing it, it was a very long video, so I wanted to make a little bit short video to explain this attack. All right, guys. So, by the way, as of today, Chrome and Firefox physically block any HTTP request to 5060 because of SAMI, because of this attack, because they cannot do anything. This thing is just, let's protect the browser, because we cannot protect all routers. We cannot let users, hey, go to your router admin and disable ALG on SIP. Who knows how to do that? Most users don't. So the browsers now disable port 5060, and it's gonna be, I made a video about it. That's actually, it happened in the beta 87 Chrome. If you make any request to port 5060, even if it's a legitimate listening port, even locally in your development server, I don't know, you're running some Visual Studio Code, you can't. They disabled that. It's an unsafe port anymore. All right, guys, that's it for today. Make sure to subscribe for more news and more interesting topics like that. I love this stuff. And good job, Sammy.
All right. Should we watch another video? Well, our title is not big enough, is it? But I feel like launching another TNT duper. Oh, fuck. Well, do we find something? There's another DNS, yeah, for 20 hours ago. Let's watch that one as well. Denial of service through DNS request discovered in Node.js. Yeah, we'll not put it in the title, but that's fine.
Guys, my name is Hussein, and Node.js just released a brand new security patch for November 16, and it has one fix: denial of service. Ooh, fancy. Through DNS request. So this is a serious one, guys. So let's discuss it and see if you really need to upgrade your Node.js and install this patch or not, right? So how about we discuss that? A Node.js application that allows an attacker to trigger a DNS request for a host of their choice could trigger a denial of service by getting the application to resolve a DNS record with a large number of responses. So let's demystify what that means. Every time, guys, you hear the word denial of service as a security patch, that means someone figured out a way to crash your backend.
Well, not crash,
Doesn't
right?
matter how. Could be by sending a malicious request, could be by overloading it, could be...
Yeah, overloading, I would consider something as denial of service, even without a crash. It can also be so slow that it's useless, or so slow that it's annoying and that enough users are pissed off. No crash required.
By sneaking into a path where you didn't anticipate any of application crash, or they could sneak in a request, a small request that cause your application to churn and pause, and as a result it denies service for other legitimate users. Whenever you see that, that means that's what necessarily happened, and this is exactly what happened here. Okay, so the bug here is a single one line of code, but only if you have a Node.js application, you use FunUp, and you're using a library called, I think, Aries, that's C-Aries, and that library resolves DNS queries. So, and what does DNS? That means give me a host name, I'll give you the IP address. That's what DNS is. And if you're using that library, And not only just that, if you're using it for hard-coded, proper hard-coded DNS that you know about, that's fine. But if you're actually exposing some APIs for other users to resolve their own DNS, then you should worry, and then you have to update that to the latest Node.js that you have, whether 12.91.
If I remove this block,
15.1, 15.2.1. Ouch, that hurt. Before we look at the code, the bug was the query to get a DNS record. You give me a host name, or you use back the IP address and the time to live. How long the query should be cached.
Oh, come on.
Before on the server, on the backend, before this cache is outdated, right? So that's the TTL, that's the correct here. So there was an array, right, of the maximum number of entries that you can save, right? So that's like, I don't know, 10 records. And because a DNS record can have multiple IP addresses, SRV records and whatnot for high availability, that number, that fixed length of the array, is not being respected. So if the destination has, I don't know, 100 IP address or 100 time to lives, then you just exceeded that. You just went out of the bound of that array, and since Node.js is written in C and C++, you just went outside your memory, so you're accessing an invalid memory location.
Isn't that CVE already?
For a crash. Let's look at the code. That's exactly what happened.
If it's
right?
in C and
That's
outside of bounds, isn't that also more dangerous?
Essentially the number, how many addresses that came back, right? And this is the array, so which is denoted as a pointer, right? And this was the original code. They were just respecting whatever you give me back as a result, whatever all of this records that came back from the DNS, just shove it into the DNS record without respecting the maximum number, the array itself, right? And they basically added a check to truncate to the maximum number, right? So that's the fix essentially. If they don't do that, the app will crash immediately, right? Because you just went outside the bound. That's how arrays work. You guys don't see this in JavaScript and garbage collection languages because you usually JavaScript don't have this idea of having, hey, you have to specify a specific array of size, and then if you cannot go beyond that. No, you can just declare an array, and you can add, and the memory will be allocated as necessary, right? And if you cut that array back, the garbage collection will kick in and clean up. This doesn't exist in C, right? This code is written in C in this case, right? So that's what I want to discuss. And in this case, if I have a Node.js app that I know it resolved my own hostname, I'm gonna create a new DNS, and I'm gonna add, I don't know, 100 IP addresses, right? And then I'm gonna just flood that Node.js service with that host name that results to I don't know, 100 IP addresses, and then I flood you with that. And I'm gonna say, hey, I expect only, as a maximum record, I expect only 3, but you gotta get 100 as a result, and your application will crash because it doesn't check that number, it doesn't respect that number that you specified, the maximum number of records that come back. Once you exceed that array size, that crashes. All right, guys, that was a quick video discussing this latest security news. I'm gonna see you in the next one. You guys stay awesome.
Okay, can we find another one? Virtual IP address.
What's going on, guys? My name is Hussein, and this is an interesting one. NPM packages being shady. and act like a malware. If you really think about it, what is NPM? It stands for Node Package Manager.
Installing this Twilio malware NPM package opens a backdoor on your developer machine.
If you use Node.js, you must have installed at least one Node package in your career as a developer in order to install tools, to install libraries, and install things that makes your life as a developer easy. And if you really think about it, it's like, can a Node package be a malware? Well, it runs code on your machine, so of course it can. However, if we really sit down and think about the coverage of what an NPM package can do, it is absolutely scary because unlike Deno, Node.js doesn't give you privileges or security tweaks to configure your application. It's a free-for-all. Whatever you run your Node.js application, the packages have the same privileges as your Node.js application, right? And
how did I survive that? I even
if you're
got
running an
damaged.
individual studio code, it just these permissions are inherited to your Node.js platform, and as a result, your Node packages. So what happened here is someone decided to brandjack. This is a new term I never heard about, but to brandjack Twilio, which is a very famous API library, into a Node package. So they call it Twilio-npm, which is couldn't get any shadier than that, right? So the actual Node package name is the Twilio Node package is called Twilio, right? But this person created a new Node package that's called Twilio-npm. The
Nice.
moment he published it or she published it, it got a lot of downloads. But what does it do? So this Sonatype, this company that is apparently they are experts in security research. They found that. I'm not surprised they found it so fast. Right? So apparently they're searching the NPM package registry all the time, or maybe they are coordinating and cooperating with the NPM security team.
Or they wrote the
for-
package
to
themselves.
scan the
Five-head.
registry for bad actors like this.
Imagine
so what does this do? Let's jump into it, guys.
Imagine you're a super successful company finding all these vulnerabilities in open source projects and finding all these backdoors and malware, and you just created all the bugs and malware yourself and build up your reputation. Awesome, huh? Imagine, well, it's probably, is that realistic? I don't know. Could be.
So there are
I mean, like if I'm a company, a normal company, maybe having a website or whatever and getting like shit ton of customers, and I'm getting hacked or whatever, or attacked by denial of service, I would probably, if I get a security company to look at my shit, if I'm like the CEO of this company, I wouldn't like manually verify. Well, what am I talking about myself? I'm maybe not very presentable, but I guess no fucking one person in this universe, well, it's, let's say not that dramatically, but it's unlikely that this person would like double check the references of that security company. He would like look at the findings, XYZ findings, found bug there, found that malicious NPM package, found this or that. But how would one verify that it's not like self-made security vulnerabilities that I found, or stuff like that? And then you're like, oh, that looks successful, they do this and they did that. Let's hire them and pay them a shitload of money because they seem to be successful. Well, I don't know. That's something you guys can do if you want to get rich fast in a sketchy way. Totally not recommending it, by the way. As always, ignore what I say. I'm just shit talking here, and my whole message is come and join and play on Lasergurkenland. Reachable under lgl.cd1.com. It has no backdoor because it's pure. Well, it has a backdoor because it's application written in Java and by fucking Microsoft. So it's as backdoor as you can get it. But join now.
3 versions for this this one, right?
Oh,
The
we have
first
one
version,
in stream chat actually, and
the first
this
version
time I
of
read
Twilio,
it.
NPM version 1.0.
Yo.
And for the people listening in the podcast, we're looking at the package.json file that
Post install
have
curl.
the script tag, and if you know, the script tag is the first thing that gets
ngRock.io, that looks
that get
sketchy.
executed. It really depends
Isn't
on the command that
ngRock.io
you execute on npm run. So if you do npm run,
ngRock.io is like for, isn't that like for bypassing NAT and shit to host something while you're developing, and abused by all these hackers for like sketchy stuff? If you see something like that in the package.json, that's a big red flag. So that company that found it super fast probably just scanned for common sketchy addresses. Like maybe they looked at all the curl commands that are in the package.json and then manually checked a few of those, or they filtered for ngRock.io addresses and other known, how's it called? There's also this DNS, or what is it called? These services that like give you a domain, or like cheap reachable domains. They are usually not found in serious packages. So that's probably a way that they found it. So he's so surprised that I found it. I think that looks really sketchy already, and that is something you can that is something obvious to set up a filter for. Of course it's cool that they did that, but it's not like some wizard shit that they did there. It is understandable in my opinion.
and then you specify like space test, then the test script will be executed, right? But there are built-in stuff that get executed regardless, like post install or pre-install. What do you want me to do after I install the package? So there are things that run automatically, and this is what they do. In their post install script tag, they had in the first version, nothing's too fancy. They're doing a curl HTTP and
a sinister task.
some
Interesting.
blah, blah, random string .ngrok.io. And I talked about ngrok, guys, and what it is exactly. Check out the video right here. Ngrok is basically a remote port forwarding platform
That's what I wanted to
allows
say.
you to spin up a server locally, and what it does, it opens a port remotely on a public machine, and then forwards anything on that remote public port that you created to your internal, and it does that usually through SSH, but it doesn't have to. So ngrok is just one implementation of this, right? It's just a free thing that you can put. But if you have a public SSH server, you can do exactly that. And I talked about SSH remote port forwarding and local port forwarding. Check out the videos if you want to understand how exactly that works. Okay.
I do that for the server, by the way. The server runs with SSH
here
forwarding.
in the first version is harmless. We're looking at curl. They're curling the HTTP. That will establish a TCP connection to, first it's going to do a DNS on
it leaks the IP address.
.ngrok.io, get the DNS, get the IP address, establish a TCP connection, establish a TLS connection, right? Curl does all of that. Daniel Stamberg does all of that for us, okay? And after that is going to do a get command and fetch the content of that page. Apparently, the Sonatype security team found that it was harmless, and maybe they published it so it is harmless as a first version, and then they follow it up with two versions that are extreme. Let's jump into it. Let's continue.
Well, if you have a bash redirect to dev
looking at
TCP,
the second version 1.02 of Twilio-npm, which is the malware. I hate the word malware. I don't know. I found it sounds like very markety, right? It's just an app that does bad things, right? Technically, what is a bad thing, right? This is just establishing a TCP connection. So you
Yeah,
can
that guy could be
argue
nice.
that anything can be treated as a bad or good, right? It's just a very philosophical question. So again, out of the scope of this video, but I just want to really understand and squeeze these terms, right? We just invent new terms for no particular reason. Malware. All right, maybe undesired behavior. So we're looking at the 0102 version.
Oh, no.
Post and install script. Here's what it does. It does a sinister task. Let's zoom in so you guys see. And for the people in the podcast, we're reading the post and install script package.json. And it says bash space dash I, which is interactive, and then slash div slash tcp slash an address for .tcp.ngrok.io slash port.
Yeah, basic.
So what does that do?
Reverse shell.
What does that do, guys? This
Basic bash reverse
is
shell.
a public presence for .tcp.ngrok.io. Tells me the fact that there is a TCP in that domain tells me that this is a TCP port forwarding, right? So it's a TCP tunnel, right? There is another idea where you can do an HTTP tunnel in ngrok, but this is a layer 4 stuff. That means just allow me to send anything in this pipe, right? And instead of just having it specific to HTTP, right? And this is the port 11425. So what the client is doing here, the moment you install twilio.npm or update it to the latest version, post install is going to execute, it's going to do a bash, and it's going to establish a TCP connection to that domain, right? First it's going to do a DNS, get the IP address, and then it's going to establish a TCP connection to that port, right?
Soon we have like verified packages in npm. Imagine like if it contains a name of a brand like Facebook, Tesla, Twilio, it has to be verified with the company, and it can be trusted over their domain or registered and something like that. That would be weird, like verified on YouTube or in social media or something like that. But maybe actually helpful security wise, that if you install it and you can verify it's actually owned by this company. You can probably visit the package and see who authored it, and I don't know how you pick names on npm or whatever, but if you would see it in the CLI already or get a warning if it includes a known brand name and is not verified, that could actually solve these brand jacking issues. But still there are other sketchy packages that are not referring to a brand, that just claim to do a task. Maybe they even do the task, but they do additional things. And there's also this issue of taking over or like switching maintainers of packages. If one rage quits to maintain a package and gives permission to someone else, that person might have malicious intents and so on. So it's a tricky situation.
Obviously, that port is open on that remote server, and anything going from my internal machine, even if I was behind a NAT and router, that will allow the connection, because we usually, firewalls don't stop outgoing connection, it stops incoming connection. Okay, that's how firewall was designed. You can block that by default if you would like to, but it's gonna cause havoc if you don't know what you're doing. Okay, so what it's doing here is establishing a TCP connection, and this is referred to as a fancy term, TCP reverse shell, right? And I love how people just throw in new terms every day, right?
Well, it's not too new. It's pretty common and useful. He's so much term bashing,
Maybe
bro.
Maybe it's known in the security world as TCP reverse shell. Oh, just TCP reverse shell, right? But to me, a reverse connection is the first principle of this, right? So we're doing a reverse connection. So we say, Hussein, what is a reverse connection? Right? I know a connection. A connection is I am a client and you are a server and I want to connect to you, right? So I establish the TCP connection. I send the send packet to you, right? And you better have that port open to which I'm sending the send packet to in order for you to respond, right? And you better, all the firewalls allow me to do that, right? Even the firewall at your end, okay? So that's a connection. A reverse connection is when the intent is an outsider want to establish a connection, not really a connection, want to establish a connection to the internal, to me as an internal behind firewalls and NAT devices, right? Someone want to establish connection to me, okay? But you can't obviously throw a connection, right? Because you have to listen to a port locally and then somehow manage the NAT. It's impossible, right? You have to do port forwarding. So nobody is gonna allow anything to the client that you want to establish connection to. So what you do is a reverse connection.
Can I still do it?
A reverse connection is nothing but a connection, right?
Ah, that was
it's just
close.
a fancy term that people invent to confuse everybody. That's the reality out there in networking. Everybody wants to be confused. So what we do is reverse the roles. Let the client establish a connection to an outside server, and that's exactly what we did. So it's
I don't think it's confusing
the
though.
client doesn't know that it's establishing a connection. We only establish a connection from the client to an outside server, so we reverse the role so that we have access to the client. So the goal here is not the connection itself. The goal here is I want to establish a tunnel between an outside world, i.e. the attacker, and the victim, which is the server, which is the client. It happens to be the client, but the victim is the user here, right? And the victim, funny enough, is the one who's establishing the connection to begin with. So it is technically a reverse connection. I still find it a little bit confusing if you think about it. To me, the whole thing is just pure client-server architecture. Who's the client and who's the server? The client is the victim in this case, and the server is the attacker, right? And if you look at it differently, it's sometimes confusing, but this is what happened. So what is happening here is the moment you do an npm install, that triggers the victim, let's call it the victim, keep saying the client, right? The victim initiates a request, a TCP connection to an attacker server. And just like that, you came to the attacker. Does that make sense? You, as a victim, you actually went to the attacker. It's not the other way around. The attacker is just sitting there. They cannot come to you. If you flip it, where the victim actually initiates the connection to the attacker, that's all good. That's called the reverse connection, right? I think just explaining reverse connection is very confusing to me. I like to explain it just as a normal connection. And just adding TCP reversals just confuse everything to me. Right?
Well, if you know what it is, it's
Again,
not confusing anymore. It's just
personal opinion.
helpful.
Everybody's allowed to have opinions and anything, right? And
No,
that's
you're
why
not
I always
allowed to
find
have opinions.
These terms a little bit confusing, but that could be me. So this is establishing a connection to the attacker server, which is for.tcp.encrypted.io11425. And once you do that, the attacker now is aware of you, because the moment we get a connection, someone just bit. What is the past tense of bite? Bitten, bite, bit, I guess bit. Someone just bit. So what you do is basically you start sending commands to kind of control this. And since you're in bash, which we did bash.i, which is interactive, you can essentially execute command elevated to whomever executed the bash, i.e. the Node.js app, i.e. the Visual Studio Code, if you're running this in Visual Studio.
Sudo npm install and you run as root.
Okay,
Yikers.
that's how they say in here in Sona types. Hey, ngrok use case is in this case becomes more clear to get a reverse
That's why you
shell
shouldn't
on the
run
victim
npm
machine
install
without
as
worrying
root.
about NAT and firewall. And the reason without worrying about NAT and firewall is we're not gonna let the attacker connect to the local machine because it's almost impossible with NAT and firewall, right? NAT, we talked about NAT, guys. Check out the video right here. It's impossible to connect from the outside to the inside. It's a private IP address. You have a private IP address. So what you do is you reverse the roles, right? you let the victim connect to outside world, and nothing is stopping the firewall. Trust any traffic coming from the inside out. It doesn't trust traffic normally coming from the outside in. Okay, this is called brand jacking attack. Brand jacking is using a brand like Twilio, which is huge, and jack. And then hijack, I guess, the attack, the victims by creating a fake brand, right?
If he's bashing again on that term, he isn't, right?
And tricking people to download it. And the tricky thing about NPM is just the moment you install it, it just
okay, he's not.
which is extremely dangerous. I don't think NPM warns you or anything like that. Says, hey, by the way, there is something about to execute. Nope. It does not. So Deno is coming as another framework, I guess, runtime. Let's call it runtime, not framework. People don't like the word framework for some reason. People keep yelling at me when I use the word framework for Node.js, or React. So I apologize. So, what were we talking about? Talking about Deno. So Deno has this idea of only allow certain execution, especially dash network. When you essentially want to run something with networking privilege, you are responsible to essentially tell it to run with networking privilege. And I believe the latest version of Deno, I'm probably mistaken, maybe I read this somewhere else, you can specify which domains you can connect to through Deno. It's like, yeah, Deno is supposed to connect only to this public IP address, or this particular IP address, or this particular domain, right? So if someone inserts like a shady ngrok domain, it's gonna be blocked, right? So you have to explicitly set that. Yeah, this creates a little bit of friction for the developer, but I guess it will increase the security, let's say, right?
Oh my god.
But yeah, a lot of people essentially what they do is code in a virtual machine. I've seen this pattern evolving now, where people spin up a Docker container and they Visual Studio code it inside the container and start coding there. So they are completely isolated. Not even a VM.
Completely.
Inside a container. I've seen that as like, woo.
Container is not
We
completely
did the
secure
homomorphic
though.
encryption episode with the IBM.
It's
the
helpful,
IBM
but
homomorphic
not
encryption.
made for
They
security.
spun up a Docker container image for us. They have a Docker image, we download it, and we spin up a container which had a Visual Studio Code with their C++ code repository. Everything is isolated nicely. So even if such attacks like this happen, no one cares, because what are you gonna get? What are you gonna steal in my Docker container? There's nothing.
Well, you can escape the Docker container and then fuck your host system. I have the feeling that some people think that Docker containers... Well, sure, for example, if I would be able to write a sketchy NPM package and establish a reverse connection easily and then name it Twilio NPM, okay, and I don't know how to escape a Docker container, sure, but I'm just a random noob. If some elaborated attacker does some research on namespaces, there are vulnerabilities, and it's also not meant for security. I think Dockerization is not to be confused with virtualization, which also has some possible flaws, I think, but it's more... I think it's more safe to use a virtual machine than a Docker container, because it's just a Docker container, right? You can escape, it's just a namespace in Linux, and you can escape those as far as I know. And it's also like, Docker probably doesn't even try to sell. I've never read Docker for security, and like it's secure if it runs in a Docker. I think nobody claims that, but I have the feeling that some people just think that it's secure because it's in a Docker and it cannot get out of the Docker. I mean, that's the idea. Sure, it's in this container and it shouldn't reach your host system or other containers. But on the other hand, it indeed does that. It's also for convenient that you can share files from your host system with your Docker and so on. It's not completely isolated, and yes, so keep that in mind. Sure, it helps. I would even lean that far out of the window and pump out the bold statement that it might solve it in most of, or if not, let's say in most of the cases, solves your security issues when it comes to npm packages. But keep in mind, if you have an elaborated attacker, he might fuck you through the container, and that goes for everything where you use container for security. If containers were the golden bullet for security and everything runs in containers now, well, we would be safe, right? But that's not the case. Well, sure, we wouldn't be safe because the container itself can be attacked, and that is in production systems bad already. But you know what I mean, right? Guys, just keep that in mind. I'm sure it helps, but you're not 100% safe. Just wanted to pressure
So
that.
literally there is nothing except my code. I mean, yeah, if you care about your code. I mean, if it's open source, you don't care. But if it is like, the attacker doesn't have access to that. All right, guys, it's an interesting article. I'm gonna leave it below for you to read. But what do you guys think about these interesting attacks? Right? Careful out there. Don't just install any npm package without actually looking at it, right? Otherwise, if you want to just test, make sure to be in a VM or something you don't care about. Otherwise, an attacker can actually access you, even if you're behind NAT. Fortunately, this is the world we live in now. All right, guys, I'm gonna leave you with this. Gonna see you in the next one. Make sure to subscribe for more coverage. Security coverage, software engineering coverage, news. I talk about backend engineering mainly, but I spread my wings everywhere. And please, whenever you see articles like this, send it my way. There's my Twitter right there. For the people in the podcast, it's HNASR. Make sure to follow. Suggest me any article that is interesting. I'll make sure to cover it if it's interesting enough, like this one. And I'm gonna see you in the next one. You guys stay awesome. Goodbye.
Okay. Yeah, I guess that's it for the stream then. Well, my advertisement game doesn't seem to be on fleek. I think most server lists where lately the players came from rated me bad due to the downtime in the last days. I will see how long I can keep this server running locally for my testing purposes. But yeah, please join. Anyways, that's it for the stream. Bye.